So probability is what? Probability is finding the possibility of something to happen. That means if I say what is the possibility that tomorrow it will rain. So what I'm doing, I'm just finding a possibility. Okay. In general language, I'll say, okay, it may rain, it may not rain, certainly it will. But in mathematics, we'll use the numbers for it. So in probability, instead of using the words, we use the numbers. And if we see, it's like this. If I draw it on a number line, the probability always lies between 0 to 1 in numbers, because as I told you, in mathematics we describe the probability in numbers. That okay, that the possibility or the probability is 0.13, 0.3. So minimum is 0 and maximum is 1, and everything lies in between it. When you are certain about something, that means if I say what's the probability that Monday will arrive after Sunday, so that's the certain thing. Definitely it's going to happen. So this is the certain one. Definitely. This is the certain one. That means one will give you the 100% surety. If I say what is the probability that February will come after July, so you know that it's not possible at all. So this is totally not possible at all. And if it's at the mid, which is half, or 0.5, which are likely, I mean, there is equal chances of something to happen. Say, for example, if I flip a coin, when I flip a coin, either I can get a head, either, or I can get a tail. There are two possibilities. So 50-50% are the chances that either I can get tail or head, and this is what equally likely. So this is how you can plot on a number line. So in terms of decimals or in terms of fraction, it lies between 0 to 1. That's when they're asking you to calculate probability. But if they're asking you to calculate probability percent, then it will be between 0 to 100%. So it will be 0% or 100%. So if the somebody is saying that probability of something to happen is 1.3, so it's not possible at all. It's impossible, because you can't define probability above 1 or 110%. Again, I will say that it's not possible at all. This is how you can describe a probability. This is a general information. Now let me see how can we calculate probability. There is a formula of calculation of it, which says probability of an event to occur is the number of times by which that event can occur. Then later on I'll explain what is event and what is all. But let me see what exactly the formula is. So number of times an event can occur over total possible outcome. Now let me focus on this word event. Event, which means whatever they are asking you in the question. Suppose the question is, a man is flipping a coin. When a man is flipping a coin, what is the probability that the tail will arrive? Tail will arrive. What the question is asking? Tail. The question is asking the probability that tail will arrive. It means that our event is tail. And total possible outcome, which means when I flip a coin, I can get head, I can get tail. Irrespective of the question, whatever they are asking, doesn't matter. But possible outcomes are, when I flip a coin, either I can get head or I can get tail. So total possible outcomes are 2. And out of these 2, which is the event here? Tail to arrive. Tail can occur only at one time. So it will be one time. So probability of tail to occur when a man flips a coin will be half. Now, quickly write this down and let me know if it's clear. Write yes if it's clear, and if there is a doubt, you can write no. Just be quick in chat section, write down. If it's clear, you can write yes so that I can move forward. Okay, now take the screenshot of this one, then we'll move forward. Okay, so I was explaining the probability. How can we define probability? Probability is always between 0 to 1. In terms of number, we define it between 0 to 1. And the probability percentage is always between 0 to 100%. If somebody says 110%, 130%, it's not possible. It's always in between that. Now, the calculation of probability is number of times an event can occur over total possible outcome. That means if I flip a coin, I took the example of a coin. When I flip a coin, and the probability is that tail will arrive. Question is asking what's the probability that tail will arrive. So tail will arrive will be your event. Whatever the question is asking will be your event. So how many times a tail can occur when you flip a coin? It's only one time possible. So event will be one here. And total possible outcomes are head and tails. That means two possible outcomes are there. You can't get a third thing when you flip a coin. So in place of total possible outcome, you'll write two. So always remember whether you'll draw the probability tree diagram or whatever the type of question you do, the probability can be calculated. Probability of a particular event will be calculated with this formula. Now quickly take the screenshot, then we'll move forward. Okay, now let me do one question. Find the probability of getting a 4 when you roll a dice. Just quickly solve this and type your answer in the chat section. Yes, very good. So as we know, the probability of something to happen or a particular event to occur is number of events by which a particular probability can occur over total possible outcome. In this, the probability of getting 4. We know whenever we roll a dice, we can get 1, 2, 3, 4, 5, 6. That's it. Because it has 6 surfaces, we can't get a number beyond 6. So total possible outcomes are 6. Now, getting a 4, that means only one time I can get a 4. When I roll a dice, only it will show me only one number at a time. So 4 I can see only at a one time. So it's gonna be 1 over 6. And probability of each and every will be 1 over 6. 1 over 6, 1 over 6, 1 over 6. Similarly for the rest of the number. From here we can see that the sum of all the events of a given experiment is always equals to 1. Experiment, that means whatever I'm doing. I'm flipping a coin. So in probability, it's known as experiment. When I roll a dice, it's your experiment. So probability of all the events in that particular experiment is always equals to 1. That means when I roll a dice, all the events are, that means events are getting 1, 2, 3, 4, 5 and 6. I can't get any number beyond it. So probability of getting 1 plus probability of getting 2 plus probability of getting 3 plus 4 plus 5 plus 6 is equals to 1. Even you can say when I flip a coin. So what are possible outcomes? Two events I can get, or possible outcomes are two. Getting either the head or the tail. So probability of getting head plus probability of getting tail should be equals to 1. This is important. So here you can see if you add probability of getting 1, it's 1 over 6 plus 1 over 6. For 3 is also 1 over 6. For 4, 1 over 6. 5, 1 over 6. 6, 1 over 6. If you add them up, you'll get 6 over 6, which turns out to be 1. And similarly for heads and tails, it's half plus half will give you 1. Now just quickly take the screenshot of this one. And if there is any doubt, you can ask. Okay, now let me do some questions. Okay. Solve 3A and 3B. Write down your answer in chat section. Okay, so let me see. It says Peter rolls an ordinary six-sided dice. It has faces marked 1, 2, 3, 4, 5, and 6. Write down the probability that he rolls a 6. So as I said, probability of getting each number is 1 by 6. We just saw. So this is going to be 1 by 6. And write down the probability that he rolls an even number. So 1, 2, 3, 4, 5, 6 are the total possible outcomes, 6. Out of which, how many are even numbers? 2, 4, and 6. That means 3. We can get 3 times if we want an even number. So it's going to be 3. So answer will be half. So for first, it's 1 by 6, and for second, it's half. Okay. Mostly you have given me the correct answer. Very good. Now let me move on to this one. Now solve 3C. Solve 3C and write down your answer. Okay, see this one. This question says, Sam then rolls a different six-sided dice 600 times. Sam rolls only at 26s. Give a possible explanation for this result. See, if a dice is going to be a unbiased dice, unbiased, that means that every number has the equal probability of occurring. That means probability of occurring 1 is 1 by 6, 2 is 1 by 6, and so on. This is the case when the dice is unbiased. But if it's unbiased, that means we are getting 1 by 6 when we are rolling a dice only one time. When we roll a dice one time, the probability of getting 6 is 1 by 6. But when we roll it for 600 times, you just need to multiply with the number of frequency. That's it. So if you multiply, you'll get 100 times. It means when you roll a dice 600 times, you will get 6 100 times. So theoretically, it should get 100 times, but instead he's getting 26s. It means the dice is biased. So always if it's like, suppose you are doing this and the expected or the theoretical answer should be 100, 200, 300, but you're not getting it, that means the particular is biased, or like wheel can be biased or dice can be biased. That means in this case, you cannot expect to have the equal probability. Is it clear to everyone? You can type yes or no. Okay, so just quickly take this screenshot and keep in mind that the probability that we are calculating is always when we are doing experiment for one time. Okay, when you are repeating it, right? Since it says send then rolls as different excited dice 600 times, then you have to multiply it with the frequency. Bias means you are not supposed to get the equally likely result every time. Unbiased, if in unbiased, you will always get the same probability 1 by 6, 1 by 6 for every number. But biased means you will get a different probability. Maybe of getting 1 is 1 by 6, getting 3 will be 4 by 6. It means if there is a six sided dice, it's not necessary that you will find 1, 2, 3, 4, 5, 6 numbers on it. Maybe it will be 1, there will be two sixes on it. Or there will be 3 1 on that dice. That's the meaning of biased. Okay, now let me do. Okay, solve 4A and 4B. Okay, now let me see. It says the probability you need to complete this table. Probability of getting blue is 1 by 3, green is 1 over 6, and you have to calculate for red. As I told you, that probability, sum of all the probabilities of all the events of a given experiment is always equals to 1. That means probability of getting blue plus probability of getting red plus probability of getting green should be equals to 1. So probability of getting blue is 1 by 3, of red we don't know, and plus green is 1 by 6, which is equals to 1. If you'll solve this, you will get x is equals to half. It's a simple linear equation. So when you solve it, you'll get x equals half. That means probability of getting red is 1 over 2. Now, if the spinner is spun 180 times, as I told you, these probabilities are 1 by 3, 1 by 2, 1 by 6 are the probabilities that you are spinning it just for one time. But if you are spinning it for 180 times, you just need to multiply it to get the number of times actually you will find that particular color. So how many times would you expect the spinner to land on blue? When you are spinning it one time, the probability is 1 by 3 that you can get 1 by 3 times a blue. But if you're spinning it for 180 times, it's gonna be 1 over 3 times 180, which is 60 times. That means blue will arrive 60 times when we spin it for 180 times. Okay, so very good. I received almost correct answers. Okay, just quickly take the screenshots, then I'll move on to the next one. Okay, now solve this question number 5. Okay, now the question says Ben flips an unbiased coin 3 times. He states he's more likely to get heads than all tails for the 3 flips. Is he correct? Explain your answer. Since it's mentioned it's an unbiased coin, that means probability of getting head is 1 over 2 and probability of getting tail is also 1 over 2. Then he states he's more likely to get tails than heads. That means what he's expecting a head and tail and then a head. Probability of this and probability of getting all the 3 tails, that is tail, tail, tail. So probability of getting head is 1 over 2 times probability of getting tail is 1 over 2. Then a head is 1 over 2, which is 1 over 8. Similarly, probability of getting tail 1 over 2, then a tail 1 over 2, then a tail 1 over 2. This is 1 over 8. So you can clearly see in both the case he is getting 1 over 2. So is he correct? No, he isn't correct at all because the likelihood of both events is equal. Let me know, is it clear? Type yes, or if there is doubt I can repeat. Okay, so these were the basic questions because we are doing probability tree diagrams here. So it's important to know the basics of probability. Now there are some rules that we have to discuss and then we can see what is probability tree diagrams. So first is known as AND rule. AND rule, which means when there is N written. Just in the previous question, we have seen the probability of getting tail, tail, and tail. That means they are asking what is the probability of getting tail and a tail and a tail, right? So whenever there is an N between it, right, you always have to multiply the probabilities. And this is the reason we have multiplied the probability in the previous question because they were asking n and n. Suppose the question is what is the probability of getting a head, then a tail, then a tail when a man flips a coin? So n is there, right? Definitely they are asking or getting one head and 2 tails. It means definitely it should be one head and 2 tails. So in this case, you need to find the probability of head multiplied by probability of getting tail multiplied by probability of getting tail, which is half times half times half, that is 1 over 2. So whenever there is n in the question, either they will write n or you can easily get to know that okay, this is n, then you always have to multiply the probability. Another rule is OR rule. Suppose the question is when a man Suppose there's a man who's rolling a dice, and the question is, what is the probability that a 4 or a 6 will arrive? A 4 or a 6, there is or in between it. That means in that case, I will add. So in case of and, you have to multiply the probabilities. In case of or, you have to add the probabilities. That means probability of getting 4 or probability of getting 6. So probability of getting 4 plus probability of getting 6. We know when we roll unbiased dice, probability of getting 4 is 1 by 6 and probability of getting 6 is 1 by 6. Answer is 2 by 6, which is 1 by 3. So always remember these two rules, they are important. This one and this one. Let me know, is it clear? Write down yes and also take the screenshot of this.
All probability 啊，講緊。
Okay. Now, the next is the types of events: independent events and dependent events. And dependent. As the name suggests, the independent events are that are not dependent on each other. The two different events that are not dependent on each other are called independent events. That means, say for example, when I flip a coin, getting a head and a tail, they are independent of each other. It means they are not depending on each other. Getting a head is not dependent on getting a tail. That are known as independent events. Whereas dependent event is, suppose there are three balls, say three red balls in a bag, and picking two red balls are definitely dependent on each other because it will change the property when there is no replacement. Suppose when there are three red balls in it, the choosing or probability of getting one red ball will be 1 over 3. Now you have already chosen. Now the probability of picking one red ball will be 1 over 2. You can clearly see that choosing the red ball at the first time definitely has changed the probability for the second time. But when you flip a coin, getting a tail is 1 by 2 and heads is 1 by 2. So you are going to get the same. There is no dependency on each other. So such types of events are what? Independent. That is flipping coins. Or here dependent. That means you can say picking a red ball from a bag 2 times without replacing. Okay, take the screenshot of this one. Okay, I'm just repeating it once again. Independent variables or independent events, that means two different events that are not depending on each other. When I flip a coin and getting a tail, suppose I'm flipping a coin 3 times. First time I flipped a coin and I got tail. Second time I flip a coin and I got head. Third time I flip a coin and I got tail. So does it changes, like, is it changing the probability of getting head or tail? No, every time you're getting half, half and half. Doesn't matter whether you're getting tail before or heads before, every time it's going to be half. That's the independent events. Probability is not changing at all. But in this case, you have seen that when I picked for the first time, when I picked the red ball, my probability was 1 over 3. Whereas when I picked it for the second time, the probability has changed and become 1 by 2. That means by picking the red ball at the first time, the probability of getting red ball in the second time has changed. That is known as dependency, right? Because one has changed the probability of another. This is called dependent events. Okay. Okay, now let me see probability tree diagrams. Why do we need the probability tree diagrams? See, when one event is either dependent or not dependent, but there is a condition over it, such probability is known as conditional probability. Conditional probability, that means when one event is happening, or one you can say one event is occurring after another event. That means when I flip a coin and I'm rolling a dice, or when I'm picking a red ball, then I'm picking a blue balls. So what is happening? The two different events, two whole different events are happening, and there is a condition over it. Such probability is known as conditional probability, and we always use tree diagrams for such. Okay. Now let me explain you by giving an example properly. Now see, it says Ben flips an unbiased coin 2 times, and you have to complete the probability tree diagram for this result. So when you are flipping or rolling a dice, or suppose you are flipping a coin simply. When you are flipping a coin for 2 times, the first time when you are flipping a coin, you can get either a head or a tail. So there is a chances either you'll get head or you'll get a tail. Now, if you have flipped it and you have received, you saw that now you have got a head, then again there will be two possibilities that you can get either head or tail in your second chance. So either head or a tail. So what we're doing, basically we are making branches. That's why it's known as a tree diagram, right? And previous event is giving the birth of the two events, right? So what's happening is, in the first chance, if you're flipping a coin, the possibility is either you can get head or you can get tail. Once suppose you have already see the head, then in the second flip either you can get head or you can get tail. Similarly, maybe in the first chance, in the first flip, you have already received one tail. In that case also, for the second flip, either you can get head or you can get tail. So either you can get heads or you can get tails. So this is what? This is for your first flip, and this is your second flip. This is how you can draw a probability tree diagram. I'm just again repeating. When you flip it for the first time, the possibility is either you can get head or you can get tail. So what's the probability of getting a head is 1 over 2. And what's the probability of getting a tail is 1 over 2 as well. Once you have flipped the first coin, in the second chance for the second flip, if suppose you have already gotten the head in the first flip, there are chances either you can get head or you can get tails in the second flip. And similarly, if you have already gotten tail in the first flip, there are again two possibilities. In the second flip, either you can get heads or you can get tails. So what are probability? Half, 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 and half. In this way, you can draw a probability tree diagram when you are flipping a coin 2 times. This is a tree diagram of it. Let me know. Is it clear? Everyone write down yes or no. Okay, just quickly take the screenshot, then we'll do some questions. Okay, now let me see what the question is. It says, hence or otherwise calculate the probability that both the flips lands on heads. That means in first flip, we have to choose heads. So in the first flip, it should be head. We have to pick this branch. And this branch, now just forget about this bottom one. Because you have already chosen the first one, so either you have to pick this one or this one. Forget about the bottom one. Okay. So in the first flip, if you are getting head, choose this one. And what is they are asking that in the second flip also you have to choose head. So you have to choose this one. So what you're doing in the first flip, head, and in the second flip, it's head. And we have seen it's half, and we know n stands for n rule is multiply. So multiply and again head 1 over 2. So answer is 1 over 5. Suppose the question is, what is the probability that in the first flip you will get head and in the second flip you will get tail? So what you will do? You will choose the head, but in the second flip it should be tail, so you will choose this branch. So it's gonna be half times half will give you 1 by 4. No, it's not 1 by 5, it's 1 by 4. Answer is 1 by 4. Okay, now just quickly take the screenshot of this one. Okay, see this question. The question says, Katie completes 2 events at her school sports day, hurdles and javelin. Complete the probability tree diagram below showing the probabilities of Katie winning each event. First, you have to complete this probability tree diagram. They have already given this diagram. You need not to draw it. Only you have to write down the numbers. So if the probability of losing is 0.4, then for point winning will be 1 minus 0.4. As I told you, that answer or the sum of all the events are always equals to 1. So in this case, either Katie will win or she will lose. So winning plus losing, probability of winning plus probability of losing is equals to 1. So for losing it's 0.4. So winning will be 1 minus 1.4, which is 0.6. Again, for the javelin, either she can win or lose. If for losing it's 0.5, so this is going to be 1 minus 0.5, which is 0.5. This was 1 minus 0.4, which is 0.6. I have to do the same again. If it's 0.6, that means for winning, it's going to be 1 minus 0.6, which is 0.4. Now just quickly let me know, is it clear what I did here? Okay, all of you take the screenshot of this one. Now see what they're asking. Calculate the probability that Katie wins one event and loses other. So first thing is, it's not mentioned that which one should be the first one. She loses one and wins another. So this can be your probability that suppose she will win hurdles but loses javelin, right? So these are the combinations. She can win hurdle and lose javelin, or she win, she lose hurdles and win javelin. These are two possible ways by which she can win one and lose another. Okay, I'm just repeating once again. The question is asking what's the probability that she will lose one and win another, but it's not mentioned which one she should be winning. So we can do two possible ways, either and or, right? Either she can win hurdle and lose javelin, or she can lose hurdle and win javelin. This is in a written statement I have written. Now in a probability way, in a calculative way, I can write probability of winning hurdles, right? Winning hurdle into, because there is an and in between it, into losing javelin. Now there's or, right? This was one statement, either or. So plus losing hurdle. So losing hurdle into probability of winning javelin. Probability of winning javelin. So let me see this one. Probability of winning hurdle. Winning hurdle was zero point 0.6. If she's winning hurdle, I have to pick this branch. Then this branch is giving rise to these two branches. So 0.6 is for winning hurdle. Now losing javelin. Losing javelin, if she will win the hurdle in the first time, then the probability of losing for javelin will be 0.5. So multiplied by 0.5. Let me know is it clear or not, or I can repeat it once again. Just quickly write yes or no. Everyone, just be quick. Only you want to give me the answer. Yes or no. Similarly, plus probability of, now just forget this branch. We have to pick. If she's losing the hurdle for the first time, right? So we have to pick this one. If she's losing the hurdle first time, and then the property is she will win the javelin for the second, this one. So which two I have selected? 0.4, losing for the first, that is losing hurdle, and winning javelin. When she lose the hurdle, then the probability of winning javelin will be zero point 0.4. So it's 0.4 times 0.4. So you can say 0.6 times 0.5 will give you 0.3. 0.4 times 0.4 is 0.016. Final answer is 0.46. So probability of winning one and losing another will be 0.46. Okay. Just quickly take the screenshot of this one. And if you have any doubt, ask. Okay. Let me do. Okay. Solve question number 3A and 3B. So don't do 3A because obviously I won't be able to see your probability tree diagram. So solve 3B. But obviously you need 3A for 3B. Okay, let me see this one. It says the probability of Ben completing his homework on any night is 1 by 3. The probability that he completes the English homework is 1 by 4. Then you have to calculate the probability that the Ben completes both pieces of work. So first we have to draw the probability tree diagram for it. So first thing is, it says probability the Ben completes the maths work and English. So we can make it like this, maths and English. So there are two possibilities. Either he will complete it or he will not complete it. Okay. So what will happen? Either he will complete or he will not complete at all. So probability of completing the maths homework is 1 by 3. So not completing will be 2 by 3, 1 minus 2 by 3, 1 minus 1 by 3, which is 2 by 3. Again, if he has completed the maths, then the possibility that either he will complete English or he will not complete the English work. So the probability of completing English is 1 by 4 and probability of not completing English work will be 1 minus 1 by 4, which is 3 by 4. Then again it will be, because they both are independent events, so obviously it's not going to change the probability. So if he's not completing, again the probability of completing and non-completing English homework will be 1 by 4 and not completing will be 3 by 4. I'm just again repeating it. It says probability of Ben completing his maths work on any night is 1 by 3 and for English is 1 by 4. The first column, the first branch is for maths and the second one is for English. Definitely there are two possibilities. Either he will complete maths or he will not complete maths at all. For completion of maths, the probability is 1 over 3 that I have written, and for not completing is 2 by 3, which is 1 minus 1 over 3. If he has completed the work for the maths, then again there are two possibilities that either he will complete English or he will not complete English. So the two branches here you can say where I have written probability of completing English is 1 by 4 and not completing English is 3 by 4. Again, the second is probability of not completing. If it's not completing, again there are two chances that either it will complete or it will not complete. He will not complete. So probability of completing English is 1 over 4 and not completing is 3 over 4. So in this way we have drawn the diagram. Now we have to solve the question. Calculate the probability that Ben completes both piece of work. Both piece of work, that means he will complete maths as well as he will complete English. So which we have to pick? We have to pick the first branch where he is completing the work, which is this one. Clearly. Forget about the bottom one where he's not completing, because question is asking only when he will complete the both piece of homework. So for completion of the first is 1 over 3. Now I have to look these two only. Because I have chosen this branch, so only I have to look this and this only. And out of this, in which he is completing the English work. In this, he is completing the English work. So probability of completion or completing maths and probability of completing English. So completing maths is 1 by 3. Since there is n in between, multiply. And completing English is 1 by 4, which is 1 over 12. So your final answer is 1 over 12. Tanish gave me the correct answer. Very good. Now quickly take the screenshot. If you have any doubt, ask me. Okay, now solve the next question. Okay, solve this one. Question number 4b. Solve 4b and give me the answer. Okay, let me understand what this question is asking. It says complete the probability tree diagram below showing the probabilities of taking counters from the bag. Okay, first we have to complete, and it's very simple because they have already mentioned the probability. If they have mentioned the probability of yellow, blue is going to be 1 minus 4 over 10, which is 6 over 10. We have already seen that why I'm doing it, because sum of all the events in a given probability is 1. So if for yellow is 4 over 10, so for blue it's gonna be 1 minus 4 over 10, that is 6 over 10. Now the thing is, it says calculate the probability that after the second pick, one blue counter, one yellow counter have been removed from the bag. And what is mentioned, that replacement is not there. If there is nothing mentioned here, right, complete the probability diagram and showing the possibilities or probabilities. If they haven't mentioned that the replacement is there or no replacement is there, you have to assume there is no replacement. No replacement, that means if you have picked blue ball, now there will be a scarcity of one blue ball. Replacement means if you have already picked one blue ball, then again you have put, or you put that blue ball back to that bag. That's the meaning of replacement. You have replaced it with another blue ball. Since in this question nothing is mentioned, that means no replacement is there. Once you have picked the blue ball, that means there's one less blue ball inside the bag. If there is one less blue ball inside the bag, that means from here I can clearly see that there are 4 yellow balls and 6 blue balls. That I can assume from here, definitely. So if in the first pick I have already picked one blue ball, only see the first one. If in the first pick, if I have already picked the one blue ball, that means now I have 5 blue balls remaining out of 9. Why 9, not 10? Because you have already picked one blue ball. So 10 minus 1 will be 9, and because you have picked one blue ball out of 6, so now it will be 5. So probability of picking blue in the second pick will be 5 over 9. For yellow, directly 1 minus 5 by 9 will give you 4 by 9. For this one, if you have already picked yellow, they have already mentioned 3 by 9, so you can easily write down 6 over 9. But you can understand this as well. If you have already picked one yellow, that means now there are one less yellow, that is 3 yellow balls, and one less total ball, which is 9. So that's why probability is 3 over 9. Just do let me know, is this clear, everyone? Right? Yes or no? Just be quick. Okay. Now it says calculate the probability that after the second pick, one blue counter and one yellow counter have been removed from the bag. That means after the second pick, in the third time, there will be one less blue ball and one less yellow ball. That's the meaning of this question, right? One counter. So calculate the probability that after second pick, one blue and one yellow counter have been removed from the bag. So there will be one less blue counter and one yellow blue counter. It means that the man has already picked one blue ball in the first pick and one yellow ball in the second pick, or one yellow ball in the first pick and one blue ball in the second pick. That's the meaning of this sentence. Let me know, is it clear? Okay, you are asking why is it 5 by 9 and 4 by 9? See, initially the probability of picking blue ball was 6 by 10 and for yellow is 4 over 10. From there, I can assume that there are 6 blue balls and 4 yellow balls, right? That's why the probability was 6 over 6 plus 4, 6 over 10, and yellow was 4 over sum of the balls, 4 over 10. Because in the first pick, you have already picked one blue ball. You have already picked one blue ball. So that means you have picked one blue ball. So remaining are 5 blue balls. And total, how many balls are there? 5 plus 4. That's why the probability of picking blue is 5 over 9. And for yellow, it will be 1 minus 5 over 9, which is 4 over 9. That's the meaning of no replacement. And that's why they are dependent variable. You can clearly see by picking one blue counter in the first pick, the probability has changed to 5 by 9 because you have already picked one blue counter. So there is one less counter. Okay. So now coming back to the part B, which says that one blue and one yellow have been removed. That means in the first pick, he has picked blue, and in second pick, he has picked yellow. Or in the first pick, he has picked yellow, and the second, he has picked blue. So if there's an in between, you have to multiply. If there's or in between, add it. So probability of blue multiplied by probability of yellow plus probability of yellow multiplied by probability of blue. So what's the probability of blue? Picking probability first time, that is 6 over 10. And then a yellow is 4 by 9 into 4 by 9. Plus probability of picking yellow in the first pick. This was the probability of picking yellow in the first pick, which are 4 over 10. And picking blue in the second pick is 6 over 9 into 6 over 9, which is 48 over 90, or 24 over 45 will be your final answer. Let me know. Is it clear? Maybe it seems to be a little bit messy. I know. But try to understand and ask me if you have any doubt. Okay, the last part. The last part is, it says that one blue counter and one yellow counter have been removed. It means that there will be one less. It means that he has already picked, the man or the woman, he has already picked one blue and one counter. But we don't know that he has picked blue in the first pick or in the second pick. That's why I have taken both the possibilities, that he will pick blue for the first and yellow in the second pick, or yellow in the first pick and blue in the second pick. And then you know how to solve this, right? The statement is important, and then you can definitely convert it into mathematical formula, right? So probability of picking blue for the first and then for the yellow, and probability of picking yellow for the first pick and blue for the second. Okay, that's the meaning of this. And then you can solve this like this one. Just take the screenshot of this one quickly. Have you all taken the screenshot? Just quickly write yes or no. Okay. See, that's it for today, right? If you want to access the worksheet, you have to join the WhatsApp group that I have already shared you. Like the link I've already shared on email. You have to join that. I'll be sharing the worksheet there. And for the solution, it will be a video actually. Okay. So then I'll share the video as well. But they are on the WhatsApp group. I am updating everything there on the WhatsApp group. So join that. Okay, it will help you. And even you can ask me doubts there as well. If while solving anything or something, if you are getting any doubt, you can post there as well. Okay. Okay, then that's it for today. Thank you and have a great day. Bye.